All right, so let's talk about polynomial inequalities. You've done linear inequalities in classes before. You may have even done a couple other like systems of inequalities where one's linear and one's nonlinear. You have two linear inequalities. But what we're going to do is we're going to actually use what we've been learning about polynomials, and we're going to solve an inequality. So I have a polynomial inequality here. We have x cubed minus 2x squared minus 3x greater than 0. All right. So really what I'm going to do with this is I'm going to treat this greater than sign as an equal sign for right now. So I'm just going to rewrite this as x cubed minus 2x squared minus 3x equals 0. And what I want to end up doing is I'm just going to solve it. So I'm going to factor out a GCF, which is x, and that gives me x squared minus 2x minus 3 still equals 0. Well, this factors, this gives me x, and x, this is going to be minus 3 and x plus 1 equals 0. And then I set each factor equal to 0. We've been doing this for a little while now. All right, and then from there, we know that x is going to equal 0, x is going to equal 3 by adding 3 to both sides, and x is going to be negative 1 when we subtract 1 from both sides. And that's if we were just solving a regular polynomial, but this is a polynomial inequality, so we need to take this a step further to actually solve the original question we had. So what we're going to do is we're going to take these, instead of these being known as zeros, x-intercepts, blah, 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 we're going to call them critical values. These are our critical values of the equation, of this equation. And what we're going to do is we're going to go back old school, and we're going to do a number line. And we're going to put these in order on a number line. So I have negative 1, I have 0, and I have 3. Now I'm going to come back here and look. I've got a greater than. So this I know has to be an open dot. Right here has to be an open dot. And right here has to be an open dot. So I'm going to do that to remind myself that it can't equal those as I get ready to write these answers. So I have my critical values here, negative 1, 0, and 3. Because we know at that point this graph is going to equal 0 at that point. But because this doesn't have the equal to part, that's why we have our open dots. I'm going to pick what's called test values. So I want to pick a number that's easy to do math with, that is to the left or less than negative 1, and that's going to be negative 10. Let me use a different color for this. And that's going to be negative 10. I'm then going to pick a number between negative 1 and 0 so I can test it because it's going to be a test value. So I'm going to do negative 0.5. I am then going to pick a number that's easy to do math with between 0 and 3. That's going to be a 1. I'm going to use 1 because that's always easy to do math with. If I can pick 0 or 1, I'm going to do that all day long. And pick a number greater than 3 that's easy to do math with. I'm going to pick 10 because that's just as easy to do math with as 1 is. So now what we're going to do is we're going to take each of these test values, I'm going to plug them in here, and I'm going to check to see if it actually works. So let's see, negative 10, so we're going to do negative 10 cubed minus 2 times negative 10 squared minus 3 times negative 10, and that's got to be greater than 0. If this is a true statement, then I'll show you what will happen. So this is a negative 1,000 minus, that's 100 times 2 is 200, and this is going to be plus 30 is greater than 0. Well, that's going to be false. Because no matter how I do this, this is never going to be a positive number because the only thing that's going to be greater than 0 is a positive number. This negative 1,000 is so dominant, such a dominant number in this expression, that it's never going to get to a positive number because the only positive number I have is 30. There's no way I'm getting to a positive number. So then I would do the same thing for the 0.5. I'm going to tell you, you will put your 0.5s here. You would do this. I'm going to tell you that this works. When you put 1 in, it does not. But when you put 10 in, it does work. So my solutions, if you remember back to Algebra 1, having to put it on a line, on a number line, would look like this. So my solutions are the numbers between negative 1 and 0 and 3 all the way out to infinity. So the way I would write the solution set would be, now because of the open dot, I'm going to have my curved parenthesis, negative 1, I'm going up to 0, curved parenthesis because it does not have the equal to part, my union because I'm jumping over, curved parenthesis to 3 and out to infinity, and that is my solution set. That is my answer for what x can be. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe as well as the bell for notifications to receive future videos on high school mathematics.